Good morning, everyone. Welcome to today's webinar entitled Delivering a Cleaner Energy Future in North America. Our speaker today is Gary Sutherland. He's team leader for external relations at Hydro-Québec, also director of external relations for Hydro-Québec International, who today is going to be presenting about some of the new transmission that Hydro-Québec is looking to build in the Northeast United States and Hydro-Québec's capacity to be the battery of the Northeast United States. So with that, Gary, I'm going to move the presentation tool over to you, and you should be able to share your screen and we can get started.
Great. So I will jump right into, first of all, before I get to discussing a study that we were involved with that was launched last year that talks about decarbonization in the Northeast, I'd just like to give you a little bit of an idea of, and I'm sure most of you know who Hydro-Québec is, but just a quick reminder, it's going to help us a little bit later to be able to follow some of the material. So we're one of the biggest electricity utilities in Canada, a major renewable energy producer in the world. We do about half of Canada's hydropower generation. So with an installed capacity of just shy of 37,000 megawatts of hydro, we are still as well a vertically integrated company. So we generate, transmit, distribute, and we also handle the vast majority of the construction of both our generation and our transmission facilities. About 99.8% of our energy is from our hydro resources, so clean, renewable. The remainder is actually off-grid systems. So we have a number of small communities, especially around the far north of Quebec, who are not attached to the grid at all, and therefore are using other sources of power, mainly diesel. We're looking at a number of possible solutions to remedy that. One of the objectives of both the company and the province of Quebec to give a cleaner energy supply to all of our citizens. A tough thing, though, some very small communities in a lot of cases, and definitely way too far away for us to be able to hook them up to the main grid. Our generation capacity in a year, last year we sold about just shy of 209 terawatt hours. So we are a big generator as that's concerned. The vast majority of people in Quebec heat with electricity, which is kind of what explains just how much volume we actually have to produce in the year. The other major aspect, though, of course, of our work here at Hydro-Québec is what we do on export markets. So once again, to give you a little bit of an idea of where we are in terms of that, we exported last year a little bit more than 36 terawatt hours to Ontario, New Brunswick in Canada. About half of our exports traditionally go to New England, and then another quarter, so about 25% into New York. And we do sell a little bit further afield down into PJM in the US and sometimes into MISO as well. So quite a big generation footprint. We are connected to those markets in the south through a series of 15 interconnections. Those interconnections have been kind of progressively built over the years, but we actually haven't done any recent outbuilds on the generation system towards the U.S. The last line went into service actually about 30 years ago. So our generation footprint and our export footprint was much different back then. So 36 terawatt hours now. I can remember years at the beginning of the 2000s when we were down at about 1 or 2 or 3 terawatt hours. So the situation has changed a great deal, just in terms of volume, and that's brought us to a realization that we really have to construct more lines into the U.S. We're fortunate in that we're in a region here in the Northeast that has some very, very high greenhouse gas reduction targets. So progressively over the years, our business strategy has changed somewhat. We went from being a supplier in these markets, but a supplier in the same way that any other supplier inside the markets would be doing their business, supplying kilowatt hours on a regular basis, to thinking a little bit more about clean energy demands and how we could respond to some of those clean energy demands. Quebec has become a member of the Western Climate Initiative. So with California, this is a cap and trade program for greenhouse gases. So that is our first question of the greenhouse gas reduction targets for the entire Northeast. The states with which we work, though, are quite far advanced as well in their own ways. They have different targets by state, but the average across the entire region is about an 80% reduction of GHGs by the year 2050. So some very forward-thinking policies in some of these states. You may have heard news about a clean energy RFP in Massachusetts, in New England, that Hydro-Québec was selected for in 2018. That's one of the projects that we're looking at these days. And a little bit more recently, the City of New York has announced that negotiations will begin with Hydro-Québec. They said Canadian hydropower, but I think we understood fairly easily that it was actually us that they were talking about, to look at the possibility of a supply contract with the City of New York that has declared that they want to go carbon neutral by 2040. So these are some exciting things coming up for us. We will be looking, of course, at transmission projects quite a bit in the next little while, as we have in the past few years. Needless to say, these are not easy projects to do. Anyone out there who has done transmission in the past, I'm sure you've run into some of the same concerns that we have been running to, that we will likely see. Of course, it's one of those necessary evils. And I guess one of the questions that we ask ourselves is how we're going to get from where we are now to an 80% reduction in GHGs throughout this entire region. This was a little bit of the reasoning that we had a few years ago when we started to look at a possible study that would look at how we can kind of get to, and what you can see on your screen is a study that was done by a university on life cycle analysis here in Montreal. And the question behind all this was, how can we get to a decarbonization of the region? What would we have to do in terms of the electricity sector? We asked CREG, which is the international research chair on life cycle analysis, to do a life cycle analysis on the kilowatt hour. So to look at various sources of energy and to determine per kilowatt hour how many grams of CO2 equivalent would be emitted. And the result that you can see is in front of you. So if I go from left to right, hydropower run of the river, we have separated from hydropower with reservoir because the carbon profile is not exactly the same. If you take those two categories together, both categories of hydro, you're probably looking at about 13 to 14 grams of CO2 equivalent for Quebec. This is a very site-specific analysis that is looking at the reservoirs that we have in Quebec on the type of territory that we have. So not readily transposable to other geographical regions in the world, who would have to basically do their own study in terms of the type of terrain that they're working on, the vegetation that is involved, the types of soil even. Moving along, nuclear, once again, a very low carbon emitting source of energy, as is wind, and solar a little bit higher because of the industrial procedure that is necessary to build the solar panels. A lot of electronics going into that, a lot of metals. We have to look at over the course of a life cycle. So of course this is on life cycle analysis, is always over a 100-year period. What is necessary to initially build that source of energy, run it for that entire period, which in the case of some technologies means that you have to rebuild it. Of course, wind or solar, we kind of estimate that those are going to have 25-year lifespans, more or less. So it's going to have to be reconstructed 4 times over its life cycle. So that kind of explains why solar is a little bit higher. Then we move towards natural gas, which is already about, if we're looking at orders of magnitude, 40 to 50 times as much as some of these other sources of low carbon energy, thermal oil even higher, and coal even higher than that. One last thing on this. This study is available, so if anybody is interested in looking at it a little bit more in detail, it's on Hydro-Québec's website, and I can send you the link directly to that. The other thing that they looked at is what kind of sources are continuous operating that we can control, that are flexible to be able to follow load, and which ones are completely intermittent. So this is when we see the distinction in the lower carbon sources, and those are the ones, of course, in a decarbonization scenario that we're going to be looking to focus on, that there is a little bit of a distinction to be made between those that we can control, that are flexible, that can follow load, and those that can't. This was the basis of kind of thinking that we had going forward on, okay, now we are in Quebec 99-point-something% clean energy in the electricity sector. We're working on other sectors that have a higher carbon footprint, such as vehicle transportation. But really in terms of Hydro-Québec's work on the electricity sector, there's not a great deal more that we can do here in Quebec. There is more that we can do on our export markets. And one of the things that we wanted to explore was what could our potential contribution be to some of those decarbonization efforts. So we had discussions with a group that is based out of Columbia University that is under the supervision of Jeffrey Sachs, the economist. Jeffrey, who is very involved in climate change circles and climate change research. And he has set up the UN Sustainable Development Solutions Network, whose mandate is really to look at decarbonization solutions for different regions in the world. And they've done this type of study on countries. They've done a Canada-wide study. They have done a U.S.-wide study. They've done it as well for certain U.S. states. They've done it for France. There are a few others that I know of. Mongolia has done the study. The one that we specifically became involved in had a couple of different questions involved. One was to look at the changes that would be required in the sector to be able to get to these goals of 80% reduction by 2050. And the second aspect was, is there value added in expanding coordination with Hydro-Québec throughout the region or not? So the pillars of the decarbonization study, you have the three of them here. So first of all, fuel switching for end use to electric sources. This is considered to be something that we would have to do on a fairly massive scale to be going, if you look at the graphs in the bottom of that first image, from about 18% today to a little over half by 2050. Now this is mainly, we'll see it a little bit later in the presentation, but it's mainly transportation and heating requests. Secondly, that source of electricity is going to have to be massively decarbonized. So we're going to have to go from an emissions per unit of a little over 200 down to 29. So a major change there. And then, of course, bring down individual use of energy through many programs of energy efficiency. One of the first conclusions of the study was that despite the fact that there are policies out there, and here you have the New York graph that they have estimated. Those policies, and then those policies can be renewable portfolio standards, they can be clean energy standards, a number of different things that we see throughout the Northeast, that they're going to bring emissions down for a period of perhaps about 10 to 15 years. But then just the growth of the economy is going to mean that emissions are going to go back up because they're just not sufficient. So here you can see this graph dips a little bit, but ends up going back to pretty much the same level. And this is where we really need to get to. So the blue line represents a kind of a trajectory that we would have to meet by the year 2015 if we were to get to that 80% reduction. Same thing for New England. New England is starting out with maybe perhaps a little bit cleaner system, but they're still going to have quite a sharp curve to get down to that gray line at the bottom, which represents a level of 80% GHG reduction throughout the region. So in terms of the study, we looked at what the Northeast would have to do. The first thing is that they're going to have to massively develop their remaining renewable sources. So we're talking onshore and offshore wind, solar, and that there's going to be a very, very large request or a very, very large requirement for storage capacity across the grid. And bringing in that much intermittent generation through especially wind power, of course, is going to create a certain number and a certain level of imbalance on the grid. Currently, New England, for example, is about 55% gas generation for electricity generation. So, of course, the vast majority of that is going to have to be replaced by wind. There is a possibility of using technologies such as biogas for a portion of that, but looking at just the supply of biogas that is available in the region, it's not sure that that's going to be a very high percentage. So we will have a problem with this imbalance on the system. And how can we respond to that imbalance? Part of it is through battery technologies, battery storage, locally placed across the grid. And I believe that the figure that Deep Decarbonization, so DDPP, the group that did the study, put forward was somewhere between 30 and 40,000 megawatts of battery capacity. So this is major. There are a lot of battery projects out there. We have one here at Hydro-Québec that is 1.2 megawatts. It's a 50-foot container. So that would be multiplied by 30,000, and we would have to find room to put those in the right places across the grid. And even that, we wonder if that is going to be enough. So some of the changes that we're going to see, I spoke a little bit earlier about passenger transportation and residential and commercial heating. Here we have a couple of different scenarios. So the reference scenario is basically with current policy, what's going to happen. And the second graph that you see is a primary DDPP, DDP, which is Deep Decarbonization Profile, which is where we see a very big increase in both heating and both passenger transportation. So much of those sectors will be transferring onto an electricity source. This means that retail sales, of course, in the electricity sector, which many of us have been experiencing as stagnating in recent years, those will probably increase by a great deal. The estimate that DDPP has done is 86% increase. So not quite doubling what they are today, but not far. One of the things that we looked at was the extent to which, given this intermittency in the Northeast that would be created as we deploy all of these different technologies, is to the extent to which reservoir hydro can offset that intermittency. Now that can be on a daily basis. If, for example, in a given day, say in New England, there's not enough wind to actually meet demand, we could flow from our reservoirs in Quebec down into New England and offset that intermittency. On another day, when there's more generation than demand merits, we have kind of the opposite problem. It's difficult to say to a wind producer, given the business case that they have for their wind turbines, to curtail their generation because it's not needed, because of course that's really, it's not helping them with their business case whatsoever. They have investments that were based on being able to sell as much energy as they can when the wind is there. And to have the market look to them and say, please curtail your system is probably not going to work. And from a carbon perspective, it doesn't make much sense either. We want those types of energies to be producing as much energy as they can when they have the resource. So in that type of situation where the wind is producing too much, for example, we could get an opposite flow happening. So that energy could be coming up into Quebec. Our reservoir system is flexible enough that we can turn it off, let reservoir levels increase, and we would use the excess energy from, in this case, New England. So that's another aspect that we looked at in quite some detail through this study is how we can match complementary sources of energy together to bring about an electrical sector that has a very, very high percentage of clean energy happening. This, of course, has a major requirement, and that is a great deal more interconnection capacity than we currently have. So Hydro-Québec right now is connected to its southern markets, if I speak just about the U.S. markets, through a system of about 4,000 megawatts of interconnection. The premise here is that we would need about 3 times that much, which is pretty much an addition of 9,000 megawatts of interconnection capacity. Or, as we quite often term this, because we are looking at a number of different projects into the U.S., they're all about 1,000 or 1,100 megawatts of capacity. It means having about 8 or 9 lines of the size of the ones that we're looking at now. So this is a very big challenge. It's one that we're not quite sure how we would get done. Once again, transmission lines, the major challenge, of course, is that nobody wants to look at them. Nobody wants them in their backyard, and it's difficult to convince people that we have to go forward if we're going to decarbonize and actually build these structures. If I look now at, from a cost issue, how this whole thing works. So no figures on the screen. This is just a graphic representation of basically how the current coordination looks versus a decarbonization scenario. So in both cases, we have what we call other energy system costs. So these are basically hardware costs. It's the poles, it's the wires that we have to put in to be able to get the energy to its end client. With current coordination, so this is no more energy flowing from Hydro-Québec and no increased transmission whatsoever. To get to those decarbonization goals, the Northeast is going to have to deploy an amazing amount, not only of clean energy, but also balancing resources right across the system. So they're going to get a cost that is fairly high. Let's call it X. What we wanted to do was compare that X cost to a cost that would have the same type of service given to the end customer, but that would involve a better coordination with Hydro-Québec. So in the improved coordination scenario, your energy system costs are still there. You still have to have the poles and the wires. Of course, those are things that are necessary. The clean energy aspect, though, is a little bit less. So if we had better coordination, the Northeast wouldn't have to build out some of those more costly projects. So of course, if they're going through a project pipeline where they're looking to put a lot of wind and solar in place, those projects are going to start out at a certain level of cost, and of course, as they move forward in time, cost is going to get higher. If we can shave off some of the most costly projects at the end of the project pipeline because you have a better coordination, you have energy coming from somewhere else that is cheaper, then that band on your graph is going to be less. The same thing can be said for balancing resources. If Hydro-Québec is involved more, we would need less balancing resources throughout the U.S. Northeast. Then you would add on to this decarbonization scenario the HQ, or the Hydro-Québec coordination. So what is this? This is added transmission, possibly, and then there are various scenarios that are looked at in the study, increased exports as well. What this gives us in the end is a cost savings. And DDPP has estimated this as being up to $4 billion at the 2050 horizon. So these are our cost savings that could be brought to the entire region. Once again, those were based on 2015 dollars. So by the time we get to 2050, this could be a very considerable amount of money. The study is available on the site of UNSDSN. I would highly suggest it's a good read. It's an interesting way of looking at things. Of course, when we're modelizing things over such a long period of time, and this is a good 30, 35 years that we're looking at, there are many different things that could happen. SDSN is particularly specialized in looking at what could possibly change from a demand side perspective. And I think that's really their strength. And they see a lot of those trends happening, and they discuss many of those trends in the report. Couple of conclusions. So once again, current policy initiatives will not get us to that carbon reduction goal by 2050. That seems fairly obvious throughout the study. We would need major changes in both the sources of energy and how they're used. And because a lot of those sources that are available throughout the Northeast, a region, by the way, where there's a lot of pressure on the nuclear energy, so another low carbon source of power, to close some of the plants. And there have been a couple of closures recently. There are a couple that have been announced. So that's not going in the right way either. Those new sources, solar and wind, being intermittent, are going to need a flexible source such as hydropower to balance them out. I spoke a little bit about balancing out from day to day. One of the things that we have perhaps not studied enough, though, on a system that has a very high penetration rate for intermittent renewables is what are your balancing needs from one season to the next? So you may get a lot of generation potential, for example, in spring on the wind side, but in many of the U.S. Northeast markets, the high demand period is in summer. And characteristically, in New York or Boston, a couple of the big big load centers for that whole region, in the middle of the summer, there doesn't tend to be a lot of wind. So there may be imbalances that go from season to season that would have to be addressed as well. And at this point, from a chemical battery perspective, I don't think we really have a solution to that. From a hydropower reservoir perspective, of course, we do. We could bank energy from one season to the next. It would involve a great deal of change in the way that we do our operations, but it's definitely a possibility. And the last, and then probably the most important consideration for the region, looking to decarbonize, it's not going to be a cheap initiative. It's going to mean a lot of major investments. And we've started to see some of the announcements for those investments. The recent announcement by Mayor de Blasio in New York had a lot of measures that addressed energy efficiency, for example, in buildings. And we're looking probably at a great deal of conversion of some of those building systems to get them off some of the more polluting sources of energy and move them onto cleaner sources. So when you look at a system that could benefit from $4 billion in annual savings at a 2050 horizon, it's a fairly important step forward, really. That's what I had for you today, and I welcome your questions. We have about half an hour, Daniel?
Yeah, we do, as much as half an hour. So feel free to submit questions to me. I have a couple that have come in already. Can you talk about what Hydro-Québec is doing to look at battery energy storage and other, sources of balancing reserves and flexibility that could fill that role?
Sure. We do actually have a battery program here at Hydro-Québec. So we have an excellence center that used to be part of our reference laboratory, so IREC, that has actually established its own center in and of itself. Looks at battery technologies not only for utility size or utility scale uses, but also, of course, for transportation, passenger transportation. Our battery, our utility scale, is a 1.2 megawatt hour battery that fits into a 50-foot container that we are currently, we've put it on our network on a couple of different places. We want to test it in different climate conditions, see how it reacts, see how fast it's recharging, if it's good in winter, which of course is a major concern for us. That technology is actually going quite well, and we hope to be able to probably commercialize it at some point in one way, shape, or form. It could be very useful on some of our far-flung or distant communities as well, the ones that we are trying to move away from use of diesel, because that's really the only option that they have today. But our thinking here at Hydro is always a little bit on two levels on that, because we're interested in the chemical battery technology, and there are huge uses for that. all over the world as various regions move towards decarbonization. It's always the thing that comes back, especially when you're working with intermittent renewables. How do you store the energy to get from one period to the next if you can't control the flow? But we are also concentrating a great deal on how we can better use our reservoir system as a battery. So this is the second aspect, and it's the one that perhaps has a much bigger potential. In our reservoir system here at Hydro, we have 177 terawatts of storage capacity. So to put that into perspective, the entire state of New York, their annual electricity consumption is 155 terawatt hours. So conceivably, with the water in our reservoirs, we could serve the New York load for an entire year without having any precipitation whatsoever. Of course, we have a great deal of precipitation here in Quebec, much of it in the form of snow, and climate change projections over the next 20, 30 years actually show that in northern climates like ours, we're going to get more rain and snow than we have in the past. So we're looking really to use that system in a much different way. Basically, these days, we will be looking to, because our biggest load and the biggest percentage of the energy that we're going to produce is in winter for heating reasons in Quebec, we're going to try and make sure that our reservoirs are at their highest level right at the beginning of winter. We use that energy throughout winter. We try to bring that level down as much as possible to be able to accommodate the spring flood. Always difficult and becoming a little bit more difficult in Quebec than it has been before. We've had quite extensive flooding this year, not because our reservoirs have not been able to absorb it, but it's much more in the south of Quebec where we don't have reservoirs that it's become a difficulty. But there's a great deal of water here. And then in the summer, of course, we would have lower reservoir levels and then start to build them up in the fall. If we were using the reservoirs as a decarbonization tool or as a storage tool, we would probably be seeing a lot more short-term fluctuations. So that's one of the jobs that our planning people in our generation branch are looking at right now, as to what extent we could use the system in a different way and be able to have more fluctuations on a daily basis and even on a seasonal basis.
Great, thanks. The project that you guys are pursuing to build new capacity to export in the United States has probably been in the news the most, is the Clean Energy Connect project with Central Maine Power. Could you perhaps just give an update on sort of where that stands and what some of the next steps are?
Definitely. So the New England Clean Energy Connect was the project that was selected by Massachusetts under their Clean Energy RFP. So the idea here is that Massachusetts wants to arrive at meeting its clean energy goals, and needed really to go out and get some additional sources of energy to be able to do that. They launched 2 RFPs in 2017. One was entitled the Clean Energy RFP, and it had a number of different technology possibilities or options that were eligible. They also did an offshore wind RFP, kind of simultaneously, a couple of months afterwards. Hydro-Québec's energy was selected for the Clean Energy RFP, but of course we need a new transmission line to be able to get it into Massachusetts. So after a couple of initial hurdles, we came across the NECEC, which was one of the options that we had bid into this RFP. It was chosen by Massachusetts, and that line currently is in regulatory approval in Maine. So it has one permit already, which is the Public Utilities Commission permit. The Department of Environmental Protection has just recently finished, or I think it has 1 or 2 more days of hearings for that permit. It requires as well a federal permit from DOE, so the presidential permit, because it's a line that goes across an international border. And then it will require permitting as well on the Quebec side, because we do have to build our transmission grid out towards the U.S. border from the current kind of transmission hubs in the south of the province. So it will require a certain number of permits on the Quebec side as well. The other aspect that whole thing is that the contracts, the power purchase contracts, are still in regulatory approval in Massachusetts. So all of that will come, I would think, sometime towards the end of 2019 or into 2020. So still a lot of steps to go through, but we're moving forward with that project.
I think you mentioned about 9,000 megawatts of additional transmission capacity that you sort of see as necessary to meet some of these clean energy goals. Is your approach in trying to supply that to move forward incrementally in terms of the approvals for that are necessary on both sides of the border, or to try and do that all at once?
So I guess it's a little bit of a difference between looking at a study that could get us to a decarbonization goal and the conditions that would be necessary for that scenario to come about, and then the day-to-day business of what are the business opportunities out there that will allow us to move forward on a specific transmission line project. Prices throughout the Northeast, energy prices are just not what they used to be. They have gone down considerably in the last 10 years or so. So it no longer makes business sense really for a company like ours to invest in a new transmission line to those markets, because we wouldn't recoup our energy costs. We wouldn't recoup the transmission costs through our energy sales, basically. So we need to have some sort of a contractual offer or an opportunity in those markets to be able to take the risk of building transmission. And that's exactly what Massachusetts has afforded us through this clean energy RFP is a long-term contract opportunity for 20 years. And so once that 20-year period is finished, of course, that line will be available for sales in the same way that all of our other lines are available for sales today, and could be an infrastructure that could potentially be used as not only just a supply source, but also because it works both ways, it could be used as a source of battery or balancing for the region. So I guess I would say that's the major objective, to be able to get us to a point where we can fully participate in a decarbonization process. But the market has to really give us the signals to be able to get to that point. So this is maybe the first. Massachusetts was a major step forward in recognizing the potential of hydropower to help those states attain their carbon reductions goals. There are a few more steps that have to be done basically before we get to a situation where we have that much transmission capacity and we can really fulfill that role.
Is the situation any different for inter-province transmission? And is there new capacity needed between New Brunswick and Ontario?
It's a little bit different in the sense that there's not perhaps so many market opportunities towards other provinces. Ontario, for example, we do sell a significant volume into Ontario, so just shy of 7 terawatt hours, I believe, in the last year. We have more than enough transmission, though, at this point to get more power into Ontario. I think we could probably increase by another 10 terawatt hours. But the need is not there, first of all, and the market signals are not there either. So the prices are just not high enough for us to send more. Ontario produces a lot of its energy with nuclear, and then there's a big wind component as well. And right now, I think they're in surplus situation, so they don't need extra power. We do have, however, an agreement in place with Ontario that was signed in, I believe, 2016 that covers the period 2017 to 2023. And it has a number of different components. It's got an energy component, it's got a capacity component, but it also has what we call a cycling component. So there are times in Ontario, because the system is nuclear and wind, and there's some hydro as well, and a little bit of natural gas, but there's a great deal of the generation capacity that is not flexible. So there were times when Ontario was seeing negative pricing. And one of the things that we did with this agreement with Ontario is that we allow them to basically bank energy in our reservoirs that we send back at a later time. So it's a little bit of the prototype that of the situation that we could have with a larger geographical area in the Northeast. We're trying it out right now with Ontario, and we'll see where that goes from here. Basically, is it something that we would be able to deploy on a much larger scale or not?
I want to ask you next about electric transportation. Last month, there were some new incentives that were rolled out at the federal level in Canada for light-duty vehicle, purchasers. Can you speak maybe to, what you see as the projected growth in electric vehicles in Canada, and whether there are plans to sort of build out transmission corridors, to supply charging for new vehicles?
Sure. I'm maybe going to limit my remarks to Quebec, though. That's really the region that I know best. Here in Quebec, because of, once again, our clean energy source, we have a much higher carbon footprint coming from the transportation sector. So it's about 42-43% of our emissions. So that's really a sector that both the government of Quebec and Hydro-Québec have been focusing on a great deal, because there's not really anything that we can do in the electricity sector here anymore, but there's a great deal that we can do in the transportation sector. So there has been a lot of work done on our side, Hydro-Québec side, to start to deploy the charging infrastructure that is really going to bring people to a level of comfort with electric vehicles on a territory as vast as ours as well, so that they feel that they can buy these cars and not have an anxiety of range or any kind of concerns like that, because they will have access to charging stations throughout the province. So we have deployed already through an initial phase of our transportation electrification initiative, about 1,700 charging stations. Some are rapid charging stations, others are not. And the plan over the next 10 years is an additional 1,600 rapid charging stations. So these are throughout all the regions in Quebec. We have also been looking at some joint projects with our neighbors to the south. So we've done a little bit of work in Vermont already. As part of the Maine project that we're doing, the transmission line, there's a fund as well for transportation electrification through Maine. So we're trying to bring the whole region as much as we can together in kind of a harmonized system, so that people can move around the region and then still find the same types of charging equipment that they do here in Quebec. Of course, the vast majority of people, they're still going to be charging either at home or in the office. So we have worked with some big companies as well to make sure that they have charging infrastructure in their parking lots. There have been a few things that have changed in building codes as well. Now, any new dwelling in Quebec, any new single-family dwelling, has to have a 220 volt plug in the garage, because they could possibly have a charging station put into the garage. So still a lot of challenges, especially in older suburbs and downtown, where there's just not necessarily the room to install all of that charging infrastructure, and in some of the more densely populated areas, trying to figure out how to do that. But it's moving forward, that whole procedure. I think we're up to about just shy of 40,000 vehicles now on the roads, and the government objective was 100,000 by the year, I believe it's 2022. So we're on our way. We are seeing sales, and partially because of the federal subsidy that came in just recently, increasing on a fairly regular basis, to the point where many automotive dealers in the province they just can't get the electric cars into the dealerships fast enough, and people have to be on waiting lists for months to get their car. So it's moving. It's moving. Did I lose you?
Oh, apologies. I was on mute. I was asking another question. I was asking a follow-up question about EVs and whether there are any investments in grid infrastructure that that Hydro-Québec is making to prepare for larger numbers of EVs on the road?
Basically, the addition of an EV is like adding, in terms of electricity charge, it's like adding a water heater to your home. So we don't really see any projected needs for additional generation within the province. On the contrary, I think we're going to start to see, because we have smart meters as well deployed throughout the province, we're going to start to see more of a situation where we will be looking to electric vehicles within the home as perhaps a source of energy for us at certain periods of the year. So, for example, we're a winter peaking system. All of our generation facilities and our transmission facilities are basically built out to be able to respond to a winter peak at a time when it's very cold here, when people have their heat turned up all the way, and then when they would not accept a lack of power on those days. So there's a lot of things that we could potentially do with vehicles if this would be on a voluntary basis with our customers. If customers would accept, for example, that the battery of their car could be used at certain times of the day to just give a little bit more power back to the grid. We're looking at a lot of schemes like that, and the smart metering system, of course, allows us to be able to think in those terms. So no, on the side of extra generation, perhaps not. We actually see this as an opportunity moving forward.
Yeah. Well, Gary, I think that we've covered all the questions that came in, and so this is probably a good place to wrap up. Thank you for today's presentation.
Thank you very much, Daniel. Great opportunity. Really appreciate speaking to all of you.